All right, good morning, everyone. This is Jason Straight and Jody Roberts with the Pass Cloud Virtual Chapter. I just want to welcome everyone to today's session. We've got Joey with us today. Joey is a database architect and, well, a senior architect and SQL Server MVP. He's been working on SQL Server and technology for over a decade, working with both Fortune 500 and smaller firms. He's a principal consultant with Denny Cherry and Associates, and lives in Pennsylvania. Welcome today, Joey. Before we get kicked off here, I just want to go over a couple housekeeping items, just to make sure everyone's informed on things that are going on with Pass and other kinds of news. So, just real quick, if this information that you're getting here today is nice and you like it, and you want to see things in either other languages or other technologies within the Microsoft stack and within data, there are a number of other virtual chapters that are out there. There's DBA, there's Big Data, there's Hebrew, there's In-Memory, there's a Women in Technology virtual chapter. And pretty much if you've got a question or if you've got an interest in other areas of data, there is a place for you here in Pass with the virtual chapters. So check those out. There are, as I mentioned, virtual chapter meetings that are coming up all the time. Unfortunately, this is the Pass deck that came from earlier this month, so of course all of the meetings are from prior to today. But there were some good ones that were going on this past month that you can check out. Most of them do get recorded. You know, the journey to becoming a consultant with David Klee. You know, one of the good ones. You know, there's lots of information out there, so take the opportunity to dig into those. There are SQL Saturdays that are coming up all the time. Usually across North America and internationally, there's 1 to 2 and sometimes up to 5 every weekend. SQL Saturdays are a way for you to go and get free training on SQL Server and data technologies. Coming up in May 2nd, there is a Dallas BI Edition SQL Saturday that's coming up. And if you happen to be in the other side of the world, other neck of the woods, on May 9th, there is a SQL Saturday in Shanghai. So check those out. You can find more information at SQLsaturday.com. If you are interested in volunteering, Pass is always looking for more volunteers. The Pass Summit is coming up here in just a few months. And at the Pass Summit, there is always a deep need for volunteers from everything from the program committee to just being a mentor or helping out first-timers with understanding what's going on at the Pass Summit and with getting around. So if you've got the free time, take a chance and volunteer with Pass. That said, if you want to volunteer for this virtual chapter, if you've got an Azure presentation that you'd like to share, please reach out to us. We're always looking for more presentations. Right now, we've got a couple more coming up over the next couple months. But we try to get 2 per month, and we still are actually looking for a presentation for the end of May. With all that said, I'm going to now pass things over to Joey. Joey, you have the floor as soon as I get this. Sure, as soon as I make you the presenter.
Thanks, Jason.
1 second here. All right, there you go, Joey. It is all yours.
Okay, hang on 1 second. Okay. There it goes. So, hello and welcome, everyone. I'm Joey D'Antoni. Today we're going to talk about SQL Server disaster recovery in Microsoft Azure. This topic is going to be kind of about building your second data center. And this is going to be a real heavy demo session. It's going to be more focused on concepts and architecture. I've built out all of these environments for a recent training class I did for a company called Opsagility. So if you want to see those in detail, you can check that out there. Like Jason mentioned, I've been doing this for about 15 years. I'm a SQL Server MVP, Microsoft Certified Solutions Expert for Business Intelligence and Data Platform. I co-wrote a paper for Microsoft last year called Using Power BI in a Hybrid Environment with Stacia Meisner. Very interesting stuff. A lot of this Azure stuff overlaps with Power BI and just having a really good understanding of how the networking works. You can find me on Twitter at jdanton. I blog at jerrydantoni.com. And finally, you can find information on this presentation at bit.ly/hybriddr. And note that is a case sensitive, so that H is capitalized as well as the D and the R on the end. So a little talk about disaster recovery. Disaster recovery has always been something that's pretty important to me. I grew up in the New Orleans area, so I started thinking a lot about disaster recovery. They're actually having a really bad storm there right as we speak. My first couple of jobs were in electric utilities, so that was something that really needed to be a 5.9 solution. And then I moved on to working in another hurricane zone in North Carolina in the U.S. So these are places that are all kind of in danger and need to have good disaster recovery plans. Every company and really every key business system in that company should have a DR plan. That doesn't mean you have to have very expensive real-time solutions. A perfectly acceptable DR plan is to say that in the event of a disaster, we will proceed without, application X, maybe a reporting application, but we will have application Y online within 2 hours. Also, you need to think about people, hardware and software resources, and how to get them in place. And really, this is the key to having good uptime, is good process. What isn't acceptable is to have this be your disaster recovery plan. And I've worked with lots of clients that have such DR plans. So this was an interesting story about backups. Jason mentioned the PASS Summit earlier, and this was at the PASS Summit a couple of years ago. We were having a little get-together at someone's rental house during the PASS Summit, and I like to cook, so I had been tasked with grilling the chicken for this get-together we had. And, I went to turn on the grill, and the grill wouldn't light, so I checked the propane tank, and the propane tank was really light, so I figured we're out of propane. So I looked, and it looked very much like this, and I looked inside the drawers the doors that are there, and there was a second propane tank. So we had a backup. Unfortunately, the second propane tank was also completely out of propane. So I like to use this little parable to kind of talk about your backups are only as good as you can recover them, and really any DR plan is really only as good as your backups. So what I'm trying to say is you should be testing restorations on a regular basis. If nothing else, this is a really good use case for the cloud. You can send a backup to Azure, spin up a VM, restore it, verify your restore, and then spin it down. You've probably only spent a few dollars in order to do that testing, and that can be really good if you have limited resources. So when crafting your disaster recovery plans, you need to start with a couple of things: recovery point objective and recovery time objective. In a nutshell, RPO is how long your system can, or how much data you can lose before you're impacting a business system. And RTO is how long your system can be down before impacting the business. Any technology system should really, or technology decision should really be driven by these business rules. The technology shouldn't drive the business. I know I've been guilty of doing that, where I implemented something because I wanted to learn a particular technology, but really you should let the business drive those decisions. After you've made these kind of decisions, you should write everything down. Typically, I like to classify these in terms of tiers of business systems, and you should also tier your business systems. So a good example might be email. Email is nearly always a tier 1 system because email drives all businesses. ERP, likely a tier 1 system. Something like reporting, not really a tier 1 system. So classify things like that. And you should get executive sign-off on that disaster recovery plan for what you're going to do. So, for example, for tier 1 systems, you might use always-on availability groups. For tier 2, you might use log shipping, and for tier 3, you might not use anything and just have it be best effort. But don't forget to keep these things up to date. Systems and business priorities change, and your DR plan should reflect this. I touched on this in the last slide, but I really can't emphasize this enough as a DBA. You're only as good as your recovery, so you really need to test your restoration processes regularly. One of my former employees, a large cable company out of the Philadelphia area, had a 55 terabyte database that was doing about 3 terabytes of transactions a day. Their applications team was complaining that they didn't have real-time DR. We also didn't have all the money in the world that we would have needed to provide real-time DR on such a system. But we were meeting with the team, and we asked them when was the last time they had tested a database restore on their 55 terabyte database. The answer was never, and the application team was really shocked when we suggested that they stop doing backups at all. In this case, the data was reproducible, but we were serious. Really, particularly with large data sets, you have to test your restores to really understand if you can even do a restore. Finally, you might want to send your backups to multiple locations. This is another great use case for Azure, which we'll talk about more shortly. In this case, blob storage, and it's kind of built into SQL Server now. Or consider a third party like Iron Mountain for that. So just a brief review of cloud computing, and I know you've probably heard these terms a lot. We have really three types, and today we're mainly going to focus on the second one, but the first is software as a service. So these would be examples like Gmail, Salesforce.com, even Office 365, the way it's constructed is largely just a software as a service offering. It's kind of a unique software as a service, but it is. Second, we have infrastructure as a service. And actually, that bullet's a little outdated. It's Microsoft Azure. Microsoft really likes to change the names of these products on us. So VMs, virtual networks, things like that. The real infrastructure as a service pieces. Amazon has AWS, and then Rackspace has similar service offerings. One really cool thing about Azure is that if you have an MSDN license, you can get some free VMs to play with. You get up to $150 a month in credit. And this can be a really nice use case for testing new features. For example, there are pre-built templates of SQL 2014 that you can run and build pretty quickly. The last major type of resource is platform as a service. And Microsoft really sees this as the long-term future of cloud computing, but they acknowledge right now that infrastructure as a service is more of the solution. And specific database resources on these platforms are available are Microsoft Azure SQL Database, also known as SQL Database, and Amazon has a similar offering called Amazon RDS. These are just a database that only exists into the cloud. So Jason, could you launch that poll right now?
There you go, Joey.
Okay, cool. So answer this question if you're using Azure for anything, even if you're like storing your blog there.
All right,
give this about 15 more seconds.
Yep. Got about 80% voted so far.
Okay.
Can we get a couple more?
There are no fabulous prizes, sadly. Okay, you can go ahead and kill it.
All right. So we got about 59% that said no, 41% that said yes.
Okay, cool. It's interesting. I've seen, really, in the last 6 months, I've seen a big shift where more and more organizations are really taking a hard look at cloud. And even I've seen the questions I've been getting asked when I've been presenting on these topics have gotten a lot deeper. So let's talk about Azure. For a long time, actually, Amazon was really the only way to go if you wanted a virtual machine in the cloud. The initial Microsoft service offering was Windows Azure, which was this really confusing offering that allowed blocks of program code to run in the cloud. It could talk to you at the time what was then called SQL Azure, but it really wasn't the same thing as what Amazon was offering in AWS. Starting in June of 2013, Microsoft started offering this infrastructure as a service model, and they've quickly accelerated the pace of development, and it's gotten really rapid. Very similar to what Amazon has, we have pre-configured VMs in the cloud. We have SQL 2014, SQL Server, all versions are available. They're all PowerShell extensible, meaning you can develop an automated process to expand out your virtual machine farms or even potentially your always-on availability groups. So there's lots of elasticity built into this process. Also, we have this concept of virtual networks. So we can connect our on-premises domain controllers and networks. So we have one unified network. One interesting thing about that is really it helps to think of Azure as just an extension, just a VM farm that's an extension of your network. Once you have the virtual network and domain controller in place, Azure will really feel no different to you than any VM in your environment. So Microsoft has Azure data centers throughout the world. This slide may be slightly outdated because I know they're working on building another one in a country in Europe that's very concerned with data privacy. There are also a couple of additional ones in the US. The cool thing to realize here is that you can geo-distribute your data across the world. You can use availability groups for this, and we'll talk about how to do that. You could even use replication. So these data centers, you can build network connections between them. So you can replicate across the world if your data needs, your users have that need for reporting. So why go to the cloud? We talk a lot about logistics that are required for a good DR plan. And a lot of times these aren't available in smaller companies. Things like redundant SANs and redundant data centers are extremely expensive. I know when I worked for the big cable company, we had 3 or 4 very large data centers throughout the country. But I've worked for pretty big companies that only had a single data center or had, maybe one real data center and then one kind of satellite operation that wasn't a real data center. It was like a closet somewhere. The other thing about DR is those resources can be sitting idle a good bit of the time, and CIOs don't typically like to have idle resources. So many smaller organizations have no real options if a disaster were to hit their primary site. The other issue a lot of smaller organizations have is having operations resources to manage a second site. The benefit of the cloud for DR is all that stuff is managed by the cloud provider. And really the pay-as-you-go thing is really fantastic, because if you need real-time DR, yeah, you're going to have to pay for your cloud servers as you go. But if you need near-time DR, you can have a solution maybe where you have your SQL servers built and up in the cloud but powered down, and you're sending your backups there. What that can enable to you to do is have a really cheap DR solution, because you're only paying for your compute resources when you're using them, and storage resources are relatively a lot cheaper. The other cool thing is lots of redundancy. So when we have one VM, we have 3 copies of it within Azure. That's all managed by Azure. You don't have to worry about that. You can also geo-replicate your storage, so you can have your backups geo-replicated across multiple Azure data centers. And I do acknowledge that the cloud isn't for every company or every system, particularly for companies that are really, really paranoid about security. I feel like Azure and AWS are both as secure as anything you can deliver on site, but there are some companies that have fear about putting their data in other places. For a while, I thought performance was an issue, but we'll talk about this on the next couple of slides. I've been doing variants on this presentation since 2013, and the scope of the systems that we can put into Azure has changed a lot, and we have a lot more resources. So when I did this in 2013, I had this slide, and I said, is this your workload? And this is a Toyota Yaris. So there's going to be a few car pictures here. I really like cars and cooking. Those are my 2 hobbies. And a Toyota Yaris is a very small car, very poor performance. And I said, is this your workload? It's probably a good fit for using virtual machines. At the time, the most we could get from a storage perspective was like 500 IOPS of volume. And I think the most we could get in terms of memory was around 28 gig, or maybe 56 gig. We didn't have really high workloads. So I said, if this is your workload, and this is a Porsche GT3 racing car, you probably want your own workload, your own dedicated hardware. Well, things changed. And I mentioned thinking of Azure as a giant virtual environment. And I think that still really fits, because if we think about a few years ago, what kinds of SQL Server workloads would we want to have put on a virtual environment, it would have been a similar discussion. We would have only wanted to put our really low-performing workloads on one. Now we have more capacity and more memory density, and we can put these kind of workloads on in virtual environments. Same thing with Azure. Last year, Microsoft introduced this G-Series VM, and these can be pretty expensive, and I'll talk a little bit about the economics of this in a second. But as you can see, we can scale up to 32 cores and almost half a terabyte in RAM, and we can get 6.5 terabytes in SSD storage. Azure Premium Storage just officially went GA last week, but it's been around for a while, so it's been in preview for a long time. But you can get up to 50,000 IOPS per VM. And 50,000 IOPS, having lots of experience working with SQL servers in multiple environments, 50,000 IOPS probably covers 97-98% of SQL Server workloads in terms of performance. Now, from a cost perspective, yes, these VMs are expensive, and that's where you really want to think about using the cloud, right? As I like to tell people, the cloud is really good for consistently low workloads. It's also very good for spiky workloads. If you have a very seasonal workload where you know it's going to change over time, and you need to scale up and scale back down, the cloud is great for you. Where it's not a good fit right now, just from the cost perspective, is, for example, if you need this standard G5 VM here, so this guy costs about $9,000 a month. If you need that level of performance 12 months a year, it probably might work out better for you to have, your own dedicated machine somewhere else or in a colo or something like that. But you have to work those numbers yourself. But for peaky workloads, it's really fantastic. Or for like what we're talking about today, DR. So now I say if your workload looks like this, and this isn't the fastest race car in the world, it's a Formula 2 car. So not Formula 1, but this is about 97% of all cars are slower than this. It's probably a good fit. The biggest question I get from nearly all clients regarding Azure is security. Probably my all-time favorite question was from a client who was really concerned about security, and their servers were in a closet with no data center. Azure data centers comply with ISO standards. Microsoft are really strict about who gets access to the data centers. Most of the services are HIPAA certified, and you're using a VPN connection of some kind, so your data is going to be encrypted end-to-end. Microsoft has also ensured that their data centers are in compliance with all EU privacy mandates, which are the strictest in the world. One thing I'll talk about a little bit too when we're going through each of these solutions, you really want to use Active Directory and VPN connections. I know that's a little outside of the scope of what we usually talk about as DBAs. With the exception of always-on availability groups, you can implement most of these solutions without VPN and DR. But you really don't want to. It's just going to make everything a lot more painful, and we'll kind of explain why. So the first thing we're going to talk about today is backup to Azure. This was something that was introduced in SQL Server 2012, Service Pack 1, CU2, and higher. So yes, it got put in the CU. It's also in SQL Server 2014 by default. And this lets you back up your database directly to Azure Blob Storage. You're going to create a credential based on your service account, and instead of saying backup database to file, or to disk rather, you're going to say backup database to URL, and that URL is going to be your Azure Blob Storage account. The other interesting thing about this feature is, starting with SQL Server 2014, backup encryption is available without the use of transparent data encryption. So in the past, if you wanted to encrypt your backups, you had to use TDE. One of the downsides of TDE is it requires SQL Server Enterprise or SQL Server Enterprise Edition. This backup encryption doesn't, and it's standalone, so you're not paying a performance penalty by encrypting your entire database. There are a couple of limits. Currently, there's a terabyte data size limit, so if you're working with very large databases, the solution might not work for you. I think that could be going away in the future, but just something to think about. There's also another feature called SQL Server Managed Backup to Azure, and this is a feature that kind of does your backups for you. It's a very interesting feature that was introduced in SQL Server 2014. All you have to specify is your storage account and your retention period. So you tell SQL Server that you want to retain your backups for 30 days, and SQL Server is going to handle doing full backups, differential backups, as well as transactional backups. And it's going to do this based on the workload. So it's going to see that X amount of workload has been done. For example, if the log growth since the last full backup has been equal to or larger than 1 gig, it's going to take a log backup. It's going to take a full backup at least once a week. Or if the log chains gets broken, backup periodically checks this and will take a full backup. So it's a pretty smart service. All you have to do is specify the retention period. Also, optionally, when you create a SQL Server VM, and this is only going to apply if you're using the new portal, not the old portal for Azure, that is, you can specify this managed backup feature just to be enabled by default. There are a couple limitations to this. Databases have to be in full recovery mode. Currently, system databases aren't supported. Azure Blob Storage is our only option, so we can't use file storage or any of the other solutions like that. And we still have that same limit where our max file size is 1 terabyte. Currently, you can't stripe these. You can't have Azure stripe these backups either, so you have to go to 1 file. So let's talking about getting connected to Azure. So one of the key things we need to have, so interestingly, that backup to URL feature works just over internet endpoints. So you don't need any sort of a VPN connection to support that. But for some of the solutions we're going to talk about next, you're going to want a VPN. So there's a couple of solutions, and there's a third that we're not going to talk about called Point-to-Site VPN. Point-to-Site VPN is really designed just for demo environments. That's a certificate-based VPN. But if you go to my blog, I have some links, some configuration on how to set it up. It's great if you just want to test a couple of things out. You don't want to use Point-to-Site VPN in any sort of enterprise environment. So the first solution is Site-to-Site VPN. So we have a couple of tools we could use here. Commonly would be either some sort of approved VPN appliance, and Microsoft has a list of approved appliances from Cisco and various other vendors you can use for this. Or you can have a Windows 2012 server in your DMZ and use remote routing and access services to connect to Azure. So Site-to-Site VPN, this is a pretty good solution if you're only rolling out a few assets in Azure. If you're rolling out a large environment, it's probably not going to be real good because you're going to be bandwidth limited because this is just going to go over the public internet. What you really want to do if you're making a full-scale investment in Azure is look at using ExpressRoute. And ExpressRoute is a dedicated low-latency connection to Azure. So this is going to give you a really high-speed connection with low latency. There are a number of service providers in the U.S. that support this. AT&T, Verizon, a couple of these other guys I've worked with, like Level 3. Zios, that's somebody I had a client recently work with. So what these guys will all give you is this direct connect to Azure. Pretty fast connection. Everything's simplified at this point, so this becomes really easy. These are the kind of things that you don't necessarily have to know as a DBA, but if you're working with your infrastructure team on configuring these sorts of solutions for your SQL servers, you'll want to make sure they're doing this, because you don't want to be in a situation where you have an availability group or log shipping or something like that, and you're going over a really slow connection and your databases are going to fall behind. The other thing you need to know about, and this is a little confusing from a terminology perspective, is cross-region networking. So we have ExpressRoute to connect a data center to another Azure data center, but if we want to connect two Azure data centers to each other, we have to have multiple network connections to each of them. And what this is going to use is a VNet to VNet connection, and this is going to take advantage of something called local networks. It's a little confusing and a little tricky to set up. Basically, you just have to point the two networks at each other. Microsoft has pretty good documentation on this online, but where you would use this solution is if you wanted your disaster recovery solution not just to be in one Azure data center, but to span multiple. Or perhaps if you wanted to use transactional replication for say maybe scaling out to various international clients to give them faster reporting. So let's talk about all of our various SQL Server disaster recovery options that we're going to have within Azure. And the first one we're going to talk about is probably my all-time favorite SQL Server DR solution because of how simple it is, log shipping. So log shipping is a very, very simple process. There is a wizard. You can write your own scripts to do it. That frequently writing your own scripts is probably more efficient. But the way log shipping works is we take a log backup on our primary server and we apply it on our secondary server. We can have multiple secondary servers. This also supports all editions of SQL Server that have log transaction logs. And I mentioned earlier the importance of having a VPN and domains. So I configured this last month for a training class I was doing without domains and without a VPN. So I had to open all these ports in my firewall. Of all the solutions, if you don't have a VPN, this is probably the least secure just because of all the ports you have to have open and weird things you have to do with service accounts. So if you're using log shipping, just make sure you have a VPN connection. It will work seamlessly. It deals with latency pretty well too, so that's another reason why this is pretty good. The pros and cons of log shipping are it's in standard edition, it supports multiple targets. Much like always-on availability groups, it does support multiple readable secondary copies. You just can't read a secondary while a transaction log is being applied. And this is really dead simple to implement in Azure, whether you're in a hybrid environment or you're in an Azure-only environment. The cons of the solution are really dependent on backup, it's dependent on backup on the primary. So if your backups start failing on your primary server, your log backups in particular, you're going to fall behind. The failover process is manual, so there's no automatic failover. You have to do it yourself. I'd say it's got reasonably high complexity, but it's not terrible. In Azure, if you're using this in Azure, you really do need network, and you want to have Active Directory or at least trusted domains that you're going across. So SQL Server Replication, and this is kind of a really high-level view of replication. Obviously, replication can be its own presentation on and of itself. There are numerous topologies and options you could come up with, but these are the nuts and bolts. So here we have a publisher, a distributor, and then a subscriber. Our publisher publishes articles. Articles are typically in the form of tables or stored procedures or whatever we're publishing at. The distributor reads the log and captures changes on that and from the distribution database, sends out those changes to our subscriber, and our subscriber gets those articles and they're available for reading. The cool thing about replication is it's the only SQL Server disaster recovery feature that doesn't require full recovery mode. So if you're bandwidth limited in terms of I/O, this is a good solution. Also, if you don't have a VPN and you don't have a domain, it's pretty secure. You can do this with SQL authentication. So there's lots of benefit there. Here's kind of what it looks like in a hybrid scenario where we have our on-prem and we're sending our transactions over the cloud. So the pros and cons of replication, we can replicate to multiple servers. You could really do some really interesting topologies using Azure here, because one of the things you can do with transactional replication is republish. So you could publish to a solution in Azure, which published out to multiple other solutions in Azure, perhaps for other clients in other parts of the world to look at that data. You also can replicate a subset of your data. There's no need to replicate everything, so you have that option, and that's for transactional replication. And it works really well in a hybrid model. This is a really pretty easy solution to implement. All of these solutions are about the same to implement as they are on-prem, assuming you have Active Directory in a network. That's the thing I can't emphasize enough. Replication has a manual failover process. There's no automatic clustering or anything like that. It has an unknown recovery point objective, so it can be hard to track how far behind your replication is. This isn't a big deal, but it's just something to be aware of, and there's some scripts that are out there that will let you monitor. The resynchronization process can be a little bit ugly. So if you're using replication and it does start to fail, it's very common that you have to reinitialize the entire subscription, which can be kind of an ugly process if you're talking about multi-terabyte databases. If you're going to fail over, there's a connection string change. The other thing to remember about replication, if you do have to fail over, it's not really bidirectional like some of these other solutions. It kind of goes one way. So in order to fail back can be a real challenge. The next thing I'm going to talk about is a feature that's been deprecated from SQL Server starting with SQL Server 2012. But knowing how many of my clients are still on older versions of SQL Server, I still like to talk about it. And I also like to talk about it because it can be a good model for a secure hybrid environment, particularly if you don't have a network or an AD, because of it's fairly easy to allow certificate-based encryption and authentication here. So this is database mirroring, and for those of you who aren't familiar, database mirroring was introduced in SQL Server 2005, Service Pack 1, and it simply sends transactions from the transaction log compressed on a database level to another database on a secondary. By default, there's no automatic failover. In order to get automatic failover, we have to pass through a witness server. The witness server is going to kind of act like Quorum in a cluster that we'll talk about in a little bit when we get to always-on availability groups. But basically, the witness server in this scenario just pulls the primary and the secondary to make sure they're both up, and as long as it can talk to them, it won't initiate a failover. But if the primary goes down, the witness will initiate the failover to the secondary, so you can get automatic failover. I mentioned secure hybrid environments. One of the things we can do is encrypt this connection and have it send the connection using certificates. So this is a good scenario if you're using, like I mentioned, you don't have AD or you don't have a VPN and you just want to have one real-time database where you're protecting into an Azure VM. The only port you would need to open would be whatever port your endpoints are on for database mirroring. So that's a pretty good solution. And your transfer at that point can be synchronous or asynchronous. Those terms are known as high performance mode, which is the asynchronous mode, and high safety mode. High performance mode is only available in the Enterprise edition of SQL Server. So the pros and cons of database mirroring. The pros are you get automatic failover with witness. Configuration happens fast and easily. So it's a little bit more complex when you're setting it up with the certificates for encryption, but it's still pretty basic. If you're not using certificates and you're going over a VPN, it's just a few mouse clicks away. Failover happens quickly and efficiently. It's been around for a while. It's a pretty mature solution. And one of my favorite features is the corrupted pages. If the primary sends a corrupted page to the secondary will attempt to repair that page based on the data it has within its database. So this can give you an extra layer of protection from database corruption, which database corruption is almost always a bad thing. And the certificate model is really good if you're going across domains or across networks. I know a lot of environments aren't able to have the same domain in each of their data centers, so that's something that is a nice feature. So some of the cons of this are the biggest one, it's per database. So if you're having the application I always like to use as an example would be SharePoint, where you have maybe 10 databases. Those applications, in order to make them fail over together, you need to script it so that all the databases, if one database fails over, they all fail over. So that's a little bit of a challenge. Asynchronous failover is only available, or asynchronous replication is only available in Enterprise Edition. What this means, and the reason why this is particularly important for a hybrid environment, typically in these hybrid connections, you're going to have relatively high latency. You may see 20 to 30 milliseconds if you're to your nearest data center. If you have ExpressRoute, it'll obviously be less than that. But a transaction in synchronous mode, a transaction isn't committed on the primary database until it reaches the transaction log on the secondary. What this means is you're not going to have you're going to impact the performance on your primary if you're going over a high latency connection. So you're going to want to use async. So Enterprise Edition is effectively a requirement for a hybrid model. It's also marked as deprecated for SQL Server 2012. I haven't seen the full features list for the next version of SQL Server, so I'm not sure it's going to be on it. This has effectively been replaced by always-on availability groups, but it's definitely something that is going away. So if it's more something you may want to take advantage of rather than designing a new solution around. And then finally, our secondaries are inaccessible, so they're idle. We can create snapshots of the databases and then access them for reading, but that comes with the headaches, whatever headaches are associated with snapshots. So before we talk about always-on availability groups, I like to do a little bit of a brief review of Windows clustering, because one of the things to remember is that with the big difference between always-on availability groups and database mirroring is database mirroring relies on a Windows on a witness server to provide quorum and do failover, whereas always-on availability groups use Windows clustering for that same effect. So the first thing I like to talk about is Quorum, because Quorum is kind of a key concept in clustering. And as a DBA, you don't necessarily need to know this. You just need to be able to check it to make sure your system admin has set it up correctly. But what you don't want here is node majority mode. So here we have a 2-node cluster. This is a fairly common scenario. And this is a Windows cluster, so this is before I'm even talking about SQL Server. But in order for the cluster service to stay running, a Windows cluster has to maintain Quorum. So in node majority mode, what that means is a majority of our nodes have to be up and reachable for the cluster to stay up. So here, if we take node 1 down to, say, perform Windows updates, our entire cluster is going to go down. That's not good. Your high availability solution, broke your entire cluster. So nothing that was dependent on the cluster service would be running. With availability groups in this scenario, you could still connect to that node 2 as the local instance of node 2, but any connections you had routing through the listener or anything like that would fail. So how you want to have this configured in a 2-node cluster is using either node and disk or node and file share majority. And for the purposes of these hybrid scenarios, you're going to want to have node and file share majority. Conceptually, this is the same thing. That disk or that file share gives us an extra voting member to our cluster. So instead of having just 2 nodes and a majority being 1, here we have 3 voting members. And in node and disk majority, we can sustain a node failure or a disk failure. One other interesting thing to note, and I've run into this with a few clients that have asked, hey, we have something in one data center that's in Philadelphia, and we have something that's in another data center in Los Angeles. Where should we put the Quorum disk or the Quorum file share? The ideal answer from Microsoft is that you should put it in a third data center, which makes sense because you want your arbitrator to be somewhere else. Unfortunately, most companies don't even have 2 data centers, much less 3. So starting with Windows 10 Server, there's a feature called Cloud Witness. So much like having a file share on a third data center, you'll be able to have your file share witness be in an Azure Blob Storage. Unfortunately, that's not going to be out until next year, but it's definitely a nice solution for that. So let's talk about always-on availability groups. This is going to look very similar to database mirroring from the perspective of what we just talked about, but there are a few key differences. The first one to realize is, like I mentioned, this is running on top of a Windows cluster. Now you'll note, especially if you've worked with clustered instances of SQL Server, when you do your installation of your databases for an availability group, by default you should do them as standalone installs of SQL Server. You can have a cluster involved in an availability group, but you don't have to. So by default, like I say, it should be a standalone install of SQL Server, just on top of a Windows cluster. There's a feature in Configuration Manager or via SQL PowerShell that you'll have to turn on once you have a SQL instance running on top of a Windows cluster that will allow you to enable your availability group. So here we have, much like we did with database mirroring, we're sending transactions from our primary to our secondary. The big difference here is we have an availability group as opposed to doing this on a database level. So we can send this to multiple databases. Here, this is a 2-node, but we can have up to 8 in SQL 2014 and up to 4 or 5, I think, in SQL 2012. Same concept, though. We have asynchronous and synchronous replication. So asynchronous is going to not impact performance in the primary. Synchronous will. So you only want to use synchronous if you have a very near secondary. You can mix within your availability group, so you can have both synchronous and async copies, which is good because you can have a local high availability copy and then a remote disaster recovery copy. We connect to our availability group using a listener, and much like if you're building a SQL Server cluster, this is an Active Directory virtual computer object that represents a virtual IP address. Where this gets weird is when we start talking about our hybrid clusters, because we build these quite differently. So if you're building this for on-prem, It's simply just part of the process at the end that you complete through the wizard. If you're building this in a hybrid model, you're going to create what's called an internal load balancer. And you're going to have to do a couple of things different. There's some good blog posts on it from Microsoft. This is really the only part of building a hybrid availability group that's a lot different than building an on-prem. It's all PowerShell, so it doesn't demo very well, so that's why we're not going to show it today. And of course, this can span multiple data centers. So here I have Washington and Chicago, which are two of the locations for our Azure data centers, Reston, Virginia, and then Chicago. But you can have this span much further. Couple of things about availability groups that are kind of unique. It does require a SQL Server Enterprise Edition for SQL Server 2012 and 2014. No two ways around that. It requires Enterprise Edition. Enterprise Edition is pretty expensive. It's licensed by the core, so pay attention to your core counts. It also requires a Windows cluster, like we've talked about. What a Windows cluster requires is that all of our servers be in the same Windows domain. This isn't a SQL Server requirement. It's simply a Windows requirement. Our databases are going to fail over as a group. So if we go back to that SharePoint example I used earlier, we're going to have all those SharePoint databases in a single availability group as opposed to having to fail them over one at a time. So if they fail over, they all fail over together. No shared storage is needed. So you do pay Microsoft more money, but you have to pay your SAN vendor less money. So you can use local storage for this, which makes it an ideal solution for virtual machines that typically don't have shared storage configured. We have both asynchronous and synchronous modes. These tie to automatic and manual failover. The only way we can have automatic failover is if we are in synchronous replication mode. Manual failover is with asynchronous. We can support up to 8 replica copies. This is designed for scale-out reading, so we can have reads scale out. The replicas can be read, so we can have readable secondaries. There's a concept known as read-only routing, where we can direct connections with read intent to our secondary. And finally, we can take backups on our secondary copies. So perhaps if you're in a hybrid model, you might want to back up everything to Azure. And these benefits are going to apply to both on-prem and hybrid AGs, but they have a lot of benefits over database mirroring. Readable secondaries are the big one. In this hybrid model, we can send our read workloads, or especially if you're using something like Power BI, you can send those to your cloud solutions. And we can offload our backups, and a lot of organizations require backups to be taken off-site. We can use Azure Blob Storage on our secondaries to support this. And we have one-button hybrid configuration. In here, there are several prerequisites to this. So I will be honest and say I've gotten this to work in a customer environment where they had ExpressRoute, but I've never actually gotten it to work at my house. So if you're trying to test this yourself, you may have to build this the hard way. But this is the prerequisites for this are assuming that you have a always-on availability group configured in place on your on-prem environment, and you have a Windows Azure subscription that will host always-on secondary replicas, and then a VPN connection of either ExpressRoute or Site VPN. There's a button you can click when you're in the Create Availability or Add Azure Replica wizard. This is only in SQL 2014. It will detect your subscription when you upload your management certificate to it, and then it will do all the hard stuff and build your availability group. I'll be honest, having done this several times, the hard stuff was already done before you can launch this wizard. The hardest part is building the cluster and getting the VPN connection in place. But this is a help, especially if you haven't done a whole lot with it. And then here's kind of how my classic demo environments work. You almost always, in any of these hybrid solutions, want to have a domain controller running in Azure. And depending on how busy your environment is, you can have a very small domain controller. So you can have it be an A1 or an A2 VM that doesn't cost a whole lot. You just want to have redundancy of resources. You're going to have a gateway. Each of your networks and each of your data centers is going to have a gateway which has a public IP address. That's where your VPN connections take place. You're going to have your SQL Server in the cloud, and then you're going to have your endpoint for your cloud internal load balancer. One other interesting thing to note is early on in Azure days, we couldn't have static IPs for our VMs. We still can't really have static IPs, but we can have an IP reservation for our Azure VMs, so we can guarantee what our IP address is going to be. So that does help. You can also now have multiple IPs on a given VM, but I think they have to be in the same subnet. And then our hybrid availability group kind of looks like this. Fairly basic. We have our on-prem. This is simplified. We have our VPN connection. We have a cluster. The one unique thing about the cluster is that the cluster name itself, that's the Windows cluster name, has to be brought online once before the cluster can be successful. So typically you're going to create a one-node cluster, bring that name online, bring it offline, and then start building the rest of your environment. That's really the big difference. In this deck, I have some resources that you can refer to. And a few of these are configuring point-to-site VPN. Like I mentioned, don't configure point-to-site VPN for your production applications, but if you want to play, particularly with like hybrid availability groups or hybrid replication, it's a great place for you just to play around with it and kind of learn some of the concepts. This always-on availability groups and hybrid IT. Listener config for always-on availability groups. Like I mentioned, that's of everything, that's really the biggest difference. There's also high availability in DR for SQL Server and VMs. So there's some other things there around how your machines fail, because yes, Azure still has failures. Remember, it's just a giant VM farm, and how you manage that in terms of resources that are good to understand. And then finally, the white paper station I wrote using Power BI in a hybrid environment. And I know it's Power BI; it's not really what we're talking about today, but I have some really good network stuff in there about how some of this stuff works, and particularly some links to decent resources around Active Directory and making sure you're in a single sign-on environment. So in summary, Azure Virtual Machines and Storage have the same HA and DR options that we have on site. I didn't mention this during the presentation, but there's even supported options to do SQL Server failover clustering now. They do involve third-party software. You can use point-to-site to test from your machine and to play around, but don't use it for production environments. Provider Connect, which is ExpressRoute, can simplify your networking needs for any hybrid environment, and I highly recommend it if you're going to use any sort of really critical production environments. You can, on the low end, from a network speed perspective, it's pretty cheap. And this is also a good model for a very, very good model for smaller shops that have mission-critical systems. The cloud really offers DR resources that there's no way you can match on-prem. So Jason, do we have any questions?
Yeah, Joe, we got a couple questions in here. And I think you might have answered one of them towards the end, but I'm going to ask it anyways. We've got, do you have a sample DR plan that you can share?
Ooh, good one. Actually, I don't, but that sounds like a good blog post. Give me a week or so and check my blog, and I'll put that together.
Okay. And then the second one is, do you need enterprise on all instances when using the witness server with mirroring?
Ooh, another good question. So first of all, the witness server can be any version of SQL Server or any edition of SQL Server. So I've used SQL Express to be my witness just because it takes up less resources and that's all you need. So the witness can be any edition. If you're using database mirroring, you do need Enterprise Edition if you want asynchronous. If you're wanting to go synchronous, and synchronous might be a good solution if you're looking to provide, say, like high availability and both of your VMs are in the same Azure data center and you're just in Azure. Synchronous could be a good model. It's also, sorry for confusing the terms, but synchronous is high safety mode. They call it high safety mode because you're not going to lose any transactions because a transaction is not committed on the primary until it reaches the log on the secondary. If you're going hybrid and you have more latency, you are going to want to use high performance mode, which is asynchronous. In that case, you would need Enterprise Edition on both machines.
All right. Well, Joey, that is all of the questions. We had a couple early on comments about some sound, but
Cool.
Those appear to have been worked out. So thank you today. Thank you for joining us today. To all the attendees that are still left, if you have interest in presenting for this virtual chapter, we would love to hear from you. Just reach out and we can get you on the schedule. Thanks for joining everyone today.
Thanks.
Thanks, guys.